Download this code from codegive.com, link in the description below. Traceroute explained, network troubleshooting and code example. Traceroute, or Tracert on Windows, is a powerful network diagnostic tool used to trace the route taken by packets from your computer to a destination host. It helps you identify network bottlenecks, pinpoint connectivity issues, and understand the structure of the Internet. This tutorial provides a comprehensive explanation of Traceroute, including its underlying mechanisms, output interpretation, troubleshooting applications, and a code example in Python. 1. Understanding the basics, how Traceroute works. Traceroute works by exploiting the time to live, TTL, field in the IP header. TTL is a mechanism designed to prevent IP packets from endlessly circulating the network in case of routing loops. Each router a packet traverses decrements the TTL value by 1. When the TTL reaches 0, the router discards the packet and sends an icmp time exceeded message back to the source. Traceroute operates as follows. 1. Initial probe ** Traceroute sends the first packet with a TTL value of 1. This packet is guaranteed to be discarded by the first router it encounters. The router then sends an icmp time exceeded message back to the source machine. 2 successive probes with increasing TTL ** Traceroute then sends subsequent packets, each with an incremented TTL value, 2, 3, 4, and so on. Each packet travels to the next router in the path until it reaches the destination or a predefined TTL limit is reached. 3 icmp time exceeded responses * each router along the path that encounters a packet with a TTL of 1 decrements the TTL to 0, discards the packet, and sends an icmp time exceeded message back to the source. Traceroute records the IP address and round trip time, RTT, of each of these responses. 4 destination reached, icmp port unreachable. When a packet finally reaches the destination with a non-zero TTL, the destination host typically sends back an icmp port unreachable message, if using UDP probes, or a TCP/RST packet, if using TCP probes, indicating that the destination port is not listening. This signifies the end of the trace. In summary, Traceroute essentially maps the path by strategically causing routers to send error messages based on TTL expiration, allowing you to see each hop in the route and measure its latency. 2. Traceroute output interpretation. The output of a typical Traceroute command looks like this, using Traceroute google.com on Linux/Mac OS. Let's break down the output. Traceroute to google.com, 142.250.185.142, 30 hops max, 60 byte packets. This line provides basic information. Traceroute to google.com, the destination host name. 142.250.185.142, the destination IP address. 30 hops max, the maximum number of hops Traceroute will attempt. This prevents endless loops. 60 byte packets, the size of the packets being sent. Hop number, the first number in each line, example 1, 2, 3, 4, indicates the hop number, the position of the router in the path. Host name/IP address, the next field shows the host name, if a reverse DNS lookup succeeds, and IP address of the router at that hop, example 192.168.1.1, 192.168.1.1. If the reverse DNS lookup fails, you'll only see the IP address. Round trip time, RTT. Traceroute typically sends 3 probes for each TTL value. The three numbers following the host name/IP address represent the RTT in milliseconds, ms, for each of those three probes. RTT is the time it takes for a packet to travel from your computer to the router and back. Important considerations when interpreting output asterisk. Asterisks, backslash, and asterisk, in the RTT field means that no response was received within the timeout period for that probe. This can indicate packet loss, a firewall blocking icmp traffic, or a router that is not configured to respond to TTL expiration. Multiple asterisks in a row, especially for later hops, can suggest a network problem. Asterisk varying RTT. RTT values can vary considerably due to network congestion, router load, and geographic distance. Significant increases in RTT between hops can pinpoint potential bottlenecks. Asterisk reverse DNS lookup issues. The failure of reverse DNS lookups to resolve IP addresses to host names doesn't necessarily indicate a problem. Many routers are not configured to have reverse DNS entries. Asterisk load balancing. Some websites use load balancing, which means that requests might be routed to different servers depending on various factors. This can lead to traceroute outputs that vary from run to run, especially in the final hop. Asterisk icmp rate limiting. Some routers and networks implement icmp rate limiting to prevent excessive icmp traffic. This can cause dropped traceroute packets and asterisks in the output, even if there isn't a significant network issue. 3. Using Traceroute for network troubleshooting. Traceroute is an invaluable tool for diagnosing network problems. Here are some common scenarios. Asterisk identifying bottlenecks. Asterisk look for hops where the RTT suddenly increases significantly. This can indicate a congested link or a slow router. Asterisk pinpointing connection failures. Asterisk if traceroute stops at a particular hop, it suggests a problem with the router at that hop or a link beyond it. Investigate further by contacting the ISP or network administrator responsible for that part of the network. Asterisk verifying network paths. Asterisk you can use Traceroute to confirm that packets are taking the expected path through the network. For example, if you're using a VPN, you can use Traceroute to verify that your traffic is being routed through the VPN server. Asterisk diagnosing DNS issues. Asterisk if you can trace route to an IP address but not to a host name, it could indicate a DNS resolution problem. Check your DNS server settings. Asterisk identifying routing loops. Asterisk although less common, Traceroute can help identify routing loops, where packets bounce between routers indefinitely. This is indicated by the same router appearing repeatedly in the output. The max hops parameter prevents infinite loops. Asterisk troubleshooting firewall issues. Asterisk firewalls can sometimes block icmp traffic, which can interfere with Traceroute. If you suspect a firewall issue, try disabling the firewall temporarily, if possible and safe, to see if Traceroute works then. 4. Traceroute variants, UDP, TCP, and icmp. The standard Traceroute utility sends UDP packets by default on most systems. However, you can also use TCP or icmp probes, which can be helpful in different situations. Asterisk UDP Traceroute asterisk the most common type. It sends UDP packets to a high, unused port, usually above 30,000. The destination host should send an icmp port unreachable message when it receives the UDP packet on the closed port. UDP traceroute is blocked more frequently by firewalls. Asterisk TCP traceroute asterisk sends TCP SYN packets to a specific port on the destination host, often port 80 or 443. The destination host will typically respond with a SYN/ACK, if the port is open, or RST, if the port is closed. TCP traceroute is sometimes preferred because it's more likely to traverse firewalls that allow HTTP/HTTPS traffic. You can usually specify TCP traceroute with a T or N flag, depending on the traceroute implementation. Example, traceroute t google.com. *icmp traceroute * sends icmp echo request, ping, packets. icmp traceroute can be useful if UDP traffic is being blocked. However, icmp traffic is also often blocked by firewalls. You can typically invoke icmp traceroute using the I flag. Example, traceroute igoogle.com. Choosing the right method ***. Start with UDP traceroute. ** If UDP is blocked, try TCP traceroute, especially on port 80 or 443. ** If both UDP and TCP are blocked, try icmp traceroute, but be aware it's also commonly blocked. 5. Code example, traceroute in Python. This Python code demonstrates a simple traceroute implementation using raw sockets. This example uses icmp echo requests. It requires root privileges, or elevated privileges, to create raw sockets. Explanation of the Python code ***. 1. Import modules ***. Socket, for network communication. Struct, for packing and unpacking data, not used in this simplified icmp version, but useful for more complex socket programming. Time, for measuring round-trip times. 2. Traceroute, destination_host, max_hops, timeout, function ***. Takes the destination host name, maximum number of hops, and timeout value as input. Resolves the destination host name to an IP address using socket.getHostByname. Creates 2 sockets. Req_socket, a raw socket to receive icmp time exceeded messages. The socket.iproto_icmp specifies that we want to receive only icmp packets. Send_socket, a UDP socket to send probe packets. Sets the timeout for the receiving socket using req_socket.setAmout. Iterates from TTL1 to max_hops. Sets the TTL option for the outgoing packet using send_socket.setSockOpt, socket.sol_ip, socket.ip_TTL, TTL. Socket.sol_ip indicates that this is an IP level option, and socket.ip_TTL specifies the time to live. Sends a UDP packet to the destination host using send_socket.sendTo. The port variable, 33434 in this example, is just an arbitrary UDP port. It doesn't matter what it is as long as it's a high, unused port. Measures the time before and after sending the packet to calculate the RTT. Receive response ***. Tries to receive data from the req_socket using req_socket.req_from. If a response is received within the timeout period. Extracts the source IP address, address 0, from the received data. Performs a reverse DNS lookup to try to get the host name from the IP address. Prints the hop number, host name/IP address, and RTT. If the source IP address of the response matches the destination IP address, the traceroute is complete. If a socket.timeout exception occurs, it means that no response was received within the timeout period, so it prints *timeout. Increments the TTL value. Closes both sockets. 3. If __name _main_block ***. This is the main execution block of the script. Prompts the user to enter the destination host name or IP address. Calls the traceroute function to perform the traceroute. Running the code asterisk. 1. Save asterisk. Save the code as a Python file, example traceroute.py. 2. Run with root/administrator privileges asterisk. Execute the script with root or administrator privileges, as raw sockets require elevated permissions. On Linux/Mac OS, use sudo python traceroute.py. On Windows, run the command prompt or PowerShell as administrator. 3. Enter destination asterisk. The script will prompt you to enter the destination host name or IP address. Example usage asterisk. Important notes about the Python code asterisk. Asterisk raw sockets and permissions asterisk. Raw sockets require root/administrator privileges because they allow you to bypass the normal network stack and construct packets directly. This capability can be used for malicious purposes, so it's restricted. Asterisk error handling asterisk. This is a simplified example, and more robust error handling would be needed for a production quality tool. You should handle exceptions like socket.getError, if the host name cannot be resolved, and other potential socket errors. Asterisk platform differences asterisk. Raw sockets can behave differently on different operating systems. The code may need adjustments for specific platforms. Asterisk firewall issues asterisk. Firewalls can block ICMP or UDP traffic, which can prevent the traceroute from working correctly. Asterisk ICMP echo requests asterisk. This example uses ICMP echo requests, like ping. Routers don't have to respond to these, so it might not always show all hops. A UDP probe version is more likely to show all hops. 6. Traceroute on different operating systems. Asterisk Linux/Mac OS asterisk. The command is typically traceroute, lowercase. You can specify options like TCP traceroute, and ICMP traceroute. Example, traceroute t google.com. Asterisk Windows asterisk. The command is tracert, note the C. It uses ICMP by default and doesn't have options for TCP traceroute built in. Example, tracertgoogle.com. There are third-party TCP traceroute tools available for Windows. 7. Advanced traceroute techniques. Asterisk Paris traceroute asterisk addresses issues with load balancing by forcing all probes to take the same path. Asterisk MTR, my traceroute a combination of ping and traceroute, providing continuous updates on network latency and packet loss. 8. Conclusion. Traceroute is a fundamental tool for network administrators and anyone interested in understanding how the Internet works. By understanding how traceroute works, how to interpret its output, and how to use it for troubleshooting, you can gain valuable insights into network performance and connectivity issues. While the provided Python code is a simplified illustration, it demonstrates the core principles behind traceroute and provides a starting point for building more sophisticated network diagnostic tools. Remember to always use traceroute responsibly and ethically, respecting the privacy and security of network resources.